Let's talk about software-defined connectivity for IoT devices with Itamar from Monogoto. Monogoto is a company. In Japanese, Monogoto means things. Well fitting for what they're doing. They crafted that concept of software-defined connectivity, making connecting devices seamless, both on the embedded side and on the backend side. This is what they're doing. We discussed during the IoT Show live streaming from IoT Stars at Embedded World, and I wanted to have this as its own episode, so enjoy. Thanks, IoT Stars, by the way, for supporting the IoT Show. IoT Stars is the IoT networking event you want to attend if you're interested in IoT, want to talk to the right people, have the right conversations. And as usual, if you like the episode and the channel, like it, subscribe, share with your friends, leave a comment, engage.
So yes, we are alive. So yes, your hair is okay. You can.
Thank you. Let me fix it for a second.
Mine is fine.
Good job.
Awesome. Thanks for coming back to the IoT Show. We are at IoT Stars in Anaheim, California, during Embedded World, North America. That's a long sentence. Itamar with me today.
Hello, everyone.
The name of the company?
Monogoto.
Monogoto. Do you know why it's called Monogoto?
That's the best way to start.
Okay, let's go there.
Sure. So Monogoto means things in Japanese. And that's a play on the IoT, right? So many people that I know today don't like the term IoT, even though it explains a lot. Because predominantly IoT was an agriculture sensor for $5.99 that you buy at your grocery store, or a humidity sensor that you put somewhere. But now, all of these connected devices, we're talking about $20,000 or $50,000 Linux on wheels, Linux with propellers, Linux with jets. That's not a typical IoT. So what we want to say is that we are a network for things, anything that requires connectivity, but not humans. We don't do humans. We don't like humans.
Yes.
Yeah.
Awesome. And so you have a term that you're using, which is software-defined connectivity.
Yep.
What does that mean?
All right. So I'll start with an example.
Let me check. Yeah. I'm just checking your microphone is on.
Perfect. So I'll start with an example. My father owned a Ford, and for 20 years, he goes to the car and it's the same car, day in, day out, minus a dent here and a dent there, or, someone scratches the window or something. But then you own a Tesla, and every week you have a different car. Now you can summon it. Now it parks on its own. Software defined means flexibility when you build products. Now, if you go back to the same example that I gave you before, if you're developing something very important like a smart meter, so someone doesn't need to go to your home to read the meter, that's extremely important. But you'll have a static firmware, and for 10 years, no one will touch it. But when we're talking about AI stuff, when we're talking about doing inference in real time, when we're talking about doing computation on the edge, it's critical to get logs, to send firmware upgrades, to get data in and out.
Yes.
And that's where software defined really comes in handy. Think about it, people who bought Tesla 2 years ago, they didn't even know the capabilities that that car will have. It's the same thing that you can see today with all these modern connected devices.
Yeah.
Software-defined connectivity allows you to be dynamic. You don't need to do a recall. You don't need to bring someone to the field or to ask the user to do something. You are dynamic. It doesn't matter if it's 2G, 3G, 4G, 5G. If it's a public or a private network, or even non-terrestrial network, the ability for a car or a drone or any GPS tracker to be connected via satellite. All of those are incorporated in a single API layer, and that's what we call software-defined connectivity.
So basically, you would do send message, receive message from your application functional code.
Yep.
And your stacks take care of the rest, understanding the different types of hardware for connectivities are there, routing where required needed.
Yep.
But I guess you also have some levers, some knobs that you can configure. Say, I prefer having this kind of connectivity, this one.
Exactly.
Because it has
real time, post-deployment. And it can go one step even deeper than that. So, you need your developer to debug a unit. So what do we do if the unit is in the field and then There's a backdoor. People realize that they can remotely connect. When you have a software defined capability, you log into the platform, you choose a device, you instantaneously open a port for one specific computer. Your developer or the DevOps wants to debug something. One specific port for one specific minute in time. You gain access, you do what you need, you get the logs, you send an update, and you close the port. So even in cyber posture, which has seen 400% increase in cyber attacks on connected devices year over year, even Gardner says that one of the top 10 reasons for problems in IoT proliferation is cybersecurity. You have enterprises who control their fleet of laptops and ATMs very, very well. But then they have 40,000 trucks and they know nothing about it.
We're talking about that with a previous guest. Window was here from Fizzle Technologies. They're specializing in embedded security.
Yep.
And she was explaining it's such a diverse set of hardware and software that it's super hard to have a generic stack that will secure everything.
Exactly.
Yeah.
And if you combine the two, that is the onion or the piece of the puzzle that sits on top of the other. You have specialized, dedicated cyber companies that do very important stuff. That's one layer up. Monogoto sits at the infrastructure layer. We enable these companies to work and provide them data monitoring, data replication, event generation, deep packet inspection, data leak prevention tools. So it works in tandem.
Yeah.
Just like you can think of Palo Alto networks or Juniper networks working on top of AWS. You have their intellectual property using the underlying APIs to provide you with the best cyber posture.
Okay.
And we copy paste the same architecture.
Okay. So I can see how we can expose a generic API for applications on embedded devices to communicate, and eventually APIs on the back end as well to get these logs and so on. In between, there's a custom hardware, right? Because on a specific hardware design, you're going to have different types of modems, different kind of modules, sums, whatever. How do you work with customers? Do they go and pick the various stacks and combine them into a middleware? How does it look like?
It's a great question because it helps me explain one of the core DNA beliefs that we have. And we call this cloud best practices. So Monogoto, we are an API platform for developers and we embed the cloud best practices. We have almost 1,000 APIs and all of them are fully documented. You can go online and you check them. When a developer works with us, he doesn't really want to speak with us. He wants to be independent. So what we see is a beautiful thing. Companies come, they start reading our documentation, and they mix and match. They take 15 APIs here and 2 APIs there, and a couple of other APIs they just use to configure their account and they don't touch anymore. And if you can see the parallelism, this is exactly like you do with AWS. They have tons of applications, tons of APIs, but not everyone needs everything.
Sure. So you're basically composing your software-defined connectivity stack with your different bricks.
100%. Exactly.
Okay.
Exactly.
I'm happy you explained that well.
Thank you so very much.
Awesome. What are the big challenges in that world? So you bring up, this combination of bricks that allow building that software-defined connectivity. 2025, what are the big challenges that you're seeing in achieving, AI at the edge, embedded at scale, those kind of things?
Oh my God, this is the best question because first of all, I can talk for hours. I don't know if you have the time, but people might not tune in. But it really explains this explosion need for connectivity that we have today. So take an example: a customer doing fleet trackers with a dashboard camera for 10 years, and they have hundreds of thousands of units deployed, even worldwide. And then they give you a call and they say, we now have AI on the edge. We need low latency. We need local breakthrough, local breakout. We need the ability to send bulks of inference logs. We need the ability to have our developers remotely monitoring. We need a different group of devices to be part of a anonymous testing group so we can get more logs. And either you tell them, oops, or you tell them, no problem, one by one. First, let's talk about the architecture. 2, let's talk about the latency. 3. And this is one of the main challenges that we see because if there is a quote that I love and I use it a lot, there's no AI without data. and there's no data without connectivity. We consider ourselves so lucky because we are the picks and shovels for this golden age. If you're building something smart, something that moves, you have to have it connected. So either you go old school, the equivalent would be an on-prem server, or you go new school, the equivalent would be the AWS, and you work with us.
Yeah, I would argue there's something in the middle, which is you bring some of the compute at the edge. It doesn't have to be cloud. It could be private cloud, heavy edge, that does that part of the communication with your leaf devices. But now you also have connectivity between your cloud and your private cloud, for public, private, and then device, right?
100%. And think about it. I love your example because it's not even one or zero. You can have a subset of your customers that you want their data to move to the cloud because you're testing debugging, the others should run on the edge. That is software defined connectivity, this flexibility. Think about it for a second. When if you want to do something in AWS, I'm using that a lot as an example. I think people can relate to that. You go to your account, you do a configuration, you don't deploy new code to your servers, etc. And it's the same thing with us. So we have customers that are using DNS manipulation, so they can send some of the traffic locally, some of the traffic externally.
Yeah.
And if you want now to decide that those 15 devices belong to the group of testing, the only thing you need to do is to update the DNS entry. So the data, instead of being sent internally, it will be sent to the cloud. And that's how you do this so dynamically in real time.
Awesome. So we don't have all night,
Unfortunately.
which is a bummer. But we do after with a drink, right? Itamar, thank you a lot.
Thank you so much. Pleasure, Oliver.
Yeah.
Thank you.
Stay tuned. We still have a couple guests for you guys. Thanks a lot for coming.